want you to picture something for a second. Imagine you are standing in the back room of a really busy dry cleaning shop in Parsippany, New Jersey.
Okay, setting the scene.
Right. And it's the late 1990s, so the air is just like thick with the smell of pressed fabric and hot steam.
And probably a lot of industrial solvents.
Exactly. Yeah, all those chemical solvents. And you were spending your entire weekend there just scrubbing stubborn stains, tagging dress shirts, and running the front register.
Wow, that is definitely not glamorous.
Not at all. Or, maybe on a different day, you are in the back of a local restaurant, just elbow deep in a sink full of greasy dishwater.
Which is brutal work. I mean, that's a grueling day-to-day reality.
It really is. That is your day-to-day life. So how does someone go from that specific reality, washing dishes and running a family dry cleaning business, to being named one of the architects of AI in Time Magazine's 2025 Person of the Year issue?
It's incredible. You were looking at a trajectory that essentially maps the entire modern history of artificial intelligence.
It really is a massive leap.
It is, but when you look closely at the actual mechanics of her life, every single step makes logical sense.
And that journey is exactly our mission for today's deep dive. We're looking at the life, the controversies, and the billion-dollar innovations of Dr. Fei-Fei Li.
A truly foundational figure.
Absolutely. And our roadmap today comes directly from her recently updated Wikipedia biography, which brings us right up to current events in early 2026.
Yeah, perfect.
Okay, let's unpack this, because the sheer volume of her accolades is almost hard to process.
Oh, yeah, the list is staggering.
I mean, we are talking about the Time 100 most influential people in AI. She has a prominent appointment to the United Nations Scientific Advisory Board.
Right.
She won the 2025 Queen Elizabeth Prize for Engineering. And, just recently, she launched a literal billion-dollar tech startup.
Yeah, and her story isn't just a biography. It is the definitive roadmap of how machine learning evolved from this theoretical, almost obscure niche in computer science to the driving force of the modern global economy.
Totally. It's like she built the bridge herself.
Exactly. Her career serves as that bridge between algorithms that just live theoretically on chalkboards and the actual AI systems that are currently reshaping the world.
But before we get into the mechanics of how she literally taught computers to see, we really need to understand the fundamental work ethic that built this career.
Right, because her early life is just a profound story of immigrant hustle.
It really is. She was born in Beijing in 1976 and grew up in Chengdu.
And then things shifted massively.
Yeah. When she was 12 years old, her father immigrated to New Jersey. And then 4 years later, when she was 16, she and her mother followed.
Right, and that is the moment she steps into the Parsippany High School experience.
Exactly. And that's when she's working those weekends at the family dry cleaning shop and, like we mentioned, picking up those dishwashing shifts just to supplement the family income.
But she balanced that intense physical labor with just elite academic performance.
Right. She graduated from high school in 1995 and headed straight to Princeton University for a degree in physics.
Which is no small feat.
No, not at all. And while she's at Princeton, she ends up writing her senior thesis on computational models for pitch.
Yes, the auditory research.
Yeah, the sources specify she was working on something called auditory binaural correlogram difference. And I have to admit, that terminology completely loses me.
It is definitely a mouthful.
It sounds like something out of a deep-level acoustics textbook. Like, what does that actually mean?
Well, to put that in more accessible terms, a binaural correlogram is essentially the mathematics of how a brain locates a sound in three-dimensional space.
Okay, so like figuring out where a noise is coming from.
Exactly. Your left ear and your right ear hear a sound at slightly different times, just fractions of a millisecond apart. And the brain calculates that difference to understand exactly where a sound is coming from in the physical world around you.
Wow, okay.
So she was trying to build computational models to replicate that biological process.
Yes.
It is highly abstract theoretical physics.
So she gets her bachelor's in 1999 doing this elite high-level physics work. But the sources point out she is still going home to New Jersey most weekends to help run that dry cleaning business.
Yeah, she never really stopped working that physical job.
I like to think of this as running two completely different high-intensity operating systems in your brain at the exact same time.
Oh, that's a great way to put it.
Right. On one side, you are compiling the abstract math of how sound waves travel through 3D space. And on the other side, you are running a highly practical, immediate interface.
Customer service, basically.
Yeah, customer service, balancing a physical cash register, and optimizing the logistics of pressing shirts.
What's fascinating here is that this grounded, real-world struggle perfectly mirrors her future approach to artificial intelligence.
How so?
Well, she never viewed technology in a vacuum because she was constantly moving between theoretical physics and running a literal storefront. She always viewed computational power in relation to human needs and practical realities.
That makes a lot of sense.
Yeah, she wasn't just solving math problems. She was looking at systems of human interaction.
And she carried that exact same practical work ethic right into her graduate studies,
Yes,
right?
exactly. She went to Caltech.
Hmm.
And supported by the Paul and Daisy Soros Fellowships for New Americans, she ultimately earned her master's and a PhD in electrical engineering by 2005.
So that ability to manage massive, complex workloads, running those dual operating systems in her head, that basically set the stage for her to solve what was arguably the biggest bottleneck in 2000s era AI.
Oh, absolutely. In the mid-2000s, artificial intelligence had a massive conceptual problem.
Right, the field had algorithms, but the algorithms were effectively starving.
Yes. The foundational architecture for deep learning, like neural networks, already existed, but it was limited.
Because of data, right.
Exactly. A neural network learns by adjusting its internal parameters or its weights based on the examples it is fed. So if you want a neural network to recognize a dog, you can't just feed it 10 pictures of a dog.
You'd need, like, way more than that.
You need to feed it thousands or millions of variations of dogs in different lighting from different angles.
And back then, they just didn't have that.
No. Algorithms were stuck because researchers only had tiny, heavily curated data sets of maybe a few thousand images.
So she becomes an assistant professor at Princeton in 2007, and she realizes the scale of this problem.
Right.
And she draws inspiration from a cognitive psychologist named Irving Biederman.
Biederman's work was key here.
Yeah, because he estimated that human beings recognize about 30,000 different object categories just by passively looking around the world as we grow up.
It's an immense amount of visual data.
So she decides the academic community needs to build a visual database that actually matches that human scale. And she calls the project ImageNet.
A massive undertaking.
Oh, wait, 2007? We didn't have the cloud infrastructure we have today. How impossible did 14 million annotated images sound to the academic community back then?
The academic community at the time thought her proposal was entirely absurd.
I mean, I would too. It sounds crazy.
Her colleagues were highly skeptical. The logistics of finding millions of images on the 2007 internet and then having a human being look at every single one to label it, it just seemed impossible.
So how does she actually pull it off?
Well, she realized she could leverage the internet itself to solve the problem. She utilized a platform called Amazon Mechanical Turk.
Oh, okay. I've heard of that.
Yeah, it's a crowdsourcing website where you can pay anonymous workers around the globe just pennies to perform micro tasks that computers cannot easily do.
Like looking at a photo and typing, "This is a coffee mug." But the quality control alone on something like that sounds like a total nightmare.
Oh, it was a huge challenge.
You have thousands of anonymous internet workers labeling images. You have to account for trolls, for people rushing through just to get paid, for genuine human error.
Exactly. She and her team had to engineer complex validation systems just to ensure the labels were actually accurate.
That's crazy. The sheer logistical management is staggering.
But they persisted, and they ultimately labeled over 14 million images across 22,000 categories.
14 million images. I mean, they didn't just build a database. They effectively gave artificial intelligence eyes.
That's exactly what it did. And that massive annotated database catalyzed something called the ImageNet Large-Scale Visual Recognition Challenge, or ILS-VRC.
Okay, what was that?
It was an annual competition that challenged researchers around the world to build software that could accurately identify the objects in her dataset.
Oh.
And that competition single-handedly kicked off the modern deep learning boom. ImageNet became the literal cornerstone for the technologies people use every single day now.
Like what kind of technologies?
Autonomous vehicles, facial recognition software, advanced medical imaging algorithms. None of that functions today without the foundational data architecture that ImageNet provided.
So you create the database that powers the modern AI economy. And naturally, the biggest tech companies in the world are going to come knocking at your door.
Inevitably.
And this transitions us right into the next phase of her career. Because when you scale technology to a global level, you encounter massive ethical complexity.
That's right. In 2017, she took a sabbatical from Stanford University, where she had become a professor and the director of the Stanford Artificial Intelligence Lab.
And where does she go?
She joined Google Cloud as their chief scientist of AI and machine learning.
Okay. And her stated focus for taking that role was democratizing artificial intelligence.
Yes. She wanted to lower the barrier to entry for smaller businesses and developers by working on products like AutoML.
Let's break down AutoML for a second, because I feel like democratizing AI can sound a bit like a corporate buzzword.
You can, yeah.
So essentially, AutoML is automated machine learning. Before tools like this, if a hospital wanted an algorithm to analyze X-rays, they had to hire a team of highly specialized PhDs to build it completely from scratch.
Which is incredibly expensive.
Exactly. But AutoML provides a pre-built platform where users can upload their own data and just let Google's infrastructure train the model for them. It makes the technology accessible to organizations that don't have infinite budgets.
But 2017 was also a pivotal year for Google in a fundamentally different arena.
Right.
That September, Google secured a contract with the United States Department of Defense called Project Maven.
Okay, Project Maven. And the sources say the stated goal of this project was to utilize artificial intelligence to automatically interpret massive amounts of video and images captured by military drone cameras.
Yes. And this contract sparked intense internal unrest at Google.
Right. The sources document that employees actively protested the company's involvement in military contracts.
And Google management attempted to address the unrest. They stated that the role was scoped specifically for non-offensive purposes, but the internal protests only grew.
Yeah, and eventually, in June of 2018, Google announced it would not seek to renew the Project Maven contract.
And during the height of this internal conflict, internal emails were leaked to reporters that highlighted Dr. Li's perspective as chief scientist.
Yeah, the leaked emails showed she was enthusiastic about Google Cloud securing a major contract, but she heavily warned her colleagues against mentioning the AI component of the project publicly.
Right. She pointed out that in the public consciousness, military AI is deeply and immediately linked with the danger of autonomous weapons and killer robots.
And reporters inevitably asked her about those leaked emails.
Of course.
When pressed, she stated very clearly that her personal philosophy is rooted in human-centered AI that benefits people in positive and benevolent ways. Right.
She asserted that it is deeply against her principles to work on any project that she believes weaponizes artificial intelligence.
And following the culmination of this controversy, in the fall of 2018, she left Google and returned to her academic work at Stanford.
Exactly.
This raises an important question regarding the fundamental nature of machine learning itself. Computer vision is the ultimate dual-use technology.
Dual use meaning it can be used for totally different things.
Right. An algorithm trained to highlight a millimeter-sized anomaly in a pediatric medical scan utilizes the exact same foundational mathematical principles as an algorithm designed to highlight a moving vehicle from a high-altitude drone feed.
Wow. Yeah, that's wild to think about.
The mathematics behind the pixel analysis are entirely neutral. The application of that mathematics is what carries the immense ethical weight.
The math doesn't have a moral compass, which means the humans guiding the data have to provide one.
And that realization leads directly into her next mission. If the mathematics are neutral, then the focus has to shift entirely to who is compiling the data sets and building the AI.
Absolutely. So upon returning to academia, she became the co-director of the Stanford Institute for Human-Centered Artificial Intelligence, or HAI.
But her work on inclusion actually predates her Google sabbatical.
It does, yeah. Back in 2017, she collaborated with Melinda French Gates and Jensen Huang to co-found a nonprofit organization called AI4AL.
Right, and AI4AL grew out of a summer camp at Stanford called Sailors, which was originally aimed at teaching ninth grade girls about AI research.
And the broader goal of AI4AL is to actively educate underrepresented groups and bring them into the tech sector.
And she has continued to push this approach into highly sensitive sectors. Like in 2023, she co-led the Raise Health initiative at Stanford.
Right, to develop responsible AI frameworks specifically for clinical care and patient safety.
Furthermore, in a 2023 interview with The Guardian, She mentioned that she accepts the media calling her the godmother of AI, specifically because she wants to use the title to highlight women's foundational contributions to the field.
Which is a powerful way to leverage that title.
So what does this all mean?
How do you mean?
Well, is she stepping back from building the hard tech to focus purely on policy and diversity? Like when someone leaves a massive corporate tech position to found nonprofits, lead health initiatives, and direct human-centered institutes, is this a full pivot into policy work?
Framing it as a pivot away from hard science is a complete misunderstanding of her
Oh,
philosophy.
really?
Oh yeah. For Dr. Lai, diversity and policy are hard tech problems. You simply cannot build a mathematically unbiased algorithm if the room of developers creating the data set lacks diverse perspectives.
Because algorithms learn exclusively from the data we feed them.
Exactly. If the data has blind spots, the AI will have blind spots.
Okay, let's give a concrete example of that for the listener. If an AI is used in a clinical care setting to recommend patient treatments, and it is trained on historical hospital data, it might learn that certain demographic groups historically received less aggressive treatments.
Right.
Without a responsible framework like Raise Health in place, the AI might mathematically recommend substandard care for a patient today simply because it is blindly mimicking the biases hidden in the old data.
And her own research explicitly targeted this phenomenon.
Yeah.
She actively worked to improve bias in image recognition by systematically removing concepts with low imageability from her own ImageNet dataset.
Okay, low imageability, we need to define that. It sounds like another piece of dense jargon.
It does. It refers to abstract concepts that don't have a single definitive visual representation.
Like what?
Think of a word like justice or friendship or beautiful. How do you take a picture of beautiful?
You can't, really. Not
Yeah.
objectively.
Exactly. If you force an AI to categorize a photo under the label beautiful, the AI isn't learning a universal truth. It is learning the personal cultural biases of the human who labeled the photo.
Oh, wow. I see.
So if developers from only one specific background curate the photos, the AI's definition of abstract concepts becomes highly skewed.
That makes total sense. So by removing these low imageability concepts from ImageNet, she was using hard data science to prevent subjective human biases from infading the core algorithms.
Precisely.
The data is literally a mirror reflecting the humans who curate it.
Exactly.
And just when it seems like she might settle comfortably into this, like, elder stateswoman role-writing frameworks, acting as a global advocate and analyzing bias, she dives right back into the absolute bleeding edge of hard technical development.
Yes, she did.
Yeah.
She took a partial academic leave from Stanford, stretching from 2024 through the end of 2025 to return to entrepreneurship.
Right. And she founded a startup called World Labs.
And the financial scale of this move is staggering.
Oh, it's massive. In 2024, World Labs raised $230 million. And by 2026, the company had reached a valuation of over $1 billion.
It's an incredible valuation. And the stated goal of World Labs is to develop something called spatial intelligence.
Okay, spatial intelligence.
They want to create artificial intelligence that can actually reason about and act within three-dimensional physical environments.
So this involves integrating visual perception with actual physical action.
Yes. We're talking about robotic systems that can perform everyday physical tasks just by a user giving them verbal instructions.
Here's where it gets really interesting. It's like AI is finally graduating from reading textbooks in a library to actually getting up and walking around the laboratory.
If we connect this to the bigger picture, spatial intelligence is the natural, inevitable evolution of ImageNet.
How so?
Well, ImageNet taught artificial intelligence how to recognize a two-dimensional picture of a coffee cup on a flat screen. It taught the machine to label pixels. World Labs is attempting to teach AI how to reach out, grasp that physical cup in three-dimensional space, and intuitively understand the real-world physics required to move the cup without spilling the water inside.
So it is the difference between perception and actual interaction.
Exactly. To do that, the AI has to understand concepts that just don't exist in a 2D photograph.
Like what kind of concepts?
It has to calculate gravity, friction, weight distribution, and occlusion.
Occlusion.
Yeah, understand that just because the back half of the cup is hidden from view, it still exists in physical space.
Oh, right. And she has been highly vocal about how global leadership manages this new physical frontier of AI.
She definitely has. At the Artificial Intelligence Action Summit in Paris in February 2025, she urged that global AI governance must be based on actual observable science, not science fiction.
So she wants a strictly empirical approach to assessing what these physical systems can and cannot do.
Right. Rather than creating legislation based on Hollywood scenarios of sentient robots taking over the world.
It all comes completely full circle. She insists on measurable physical reality.
Always.
She started her career mapping the physics of sound waves while literally managing the physical logistics of a dry cleaner. And whether she is building a 14 million image database or a billion-dollar spatial robotics company, her focus remains entirely grounded in the physical world and how technology interacts with real human environments.
It is remarkably consistent.
It truly is an incredible journey. We have mapped her trajectory from a high schooler washing dishes and scrubbing stains in New Jersey to a researcher who literally defined the field of computer vision.
And we've seen her navigate the intense complexities of military contracts and advocate fiercely to remove bias from foundational data sets.
And now we are watching her attempt to map the physics of our 3D world with a billion-dollar startup. It's just wild.
It really is.
But as we wrap up this deep dive, I want to leave you with a thought. Something for you to mull over as we watch this future of spatial intelligence unfold in real time. If World Labs fully succeeds, if AI systems and robots can eventually reason, navigate, and interact perfectly within our physical world without making a single spatial mistake, what happens to the uniquely human experience of physical trial and error?
That's a deep question.
Think about your own life. So much of human discovery, art, and innovation is deeply rooted in physical clumsiness.
Right?
It is dropping a beaker in a chemistry lab and discovering a new compound. It is bumping into a table and spilling paint to create a new artistic technique. It is the accidental serendipity of a physical mistake.
Yeah, those happy accidents.
Exactly. So if we are eventually sharing our homes and workspaces with flawless spatial AI that perfectly calculates friction and gravity, an AI that never drops the coffee cup, do we slowly lose the magic of our own physical imperfections?